Alright, I think we're up. Sorry, just have to excuse me for a minute. Thank you. Welcome back. This is episode 2 of live coding. So this is going to be more HackerRank problems in C++. My name is Carlton, if you don't know that. I haven't seen the screen before. I'm a C++ developer working here in London, Ontario. It's just about 4:30 in the morning. I prefer to work, if I'm going to do like what I'm doing now, which is like studying or anything like that, I prefer to do it super early in the morning. I haven't worked out yet. I'll do that after this. But I've decided to just really start focusing on doing more coding work in the morning. So you'll probably see a lot more 4:30s. You'll probably see a lot more of me drinking tea while I work. But let's get into it. I really hate long intros. So today we're going to do more C++ problems. This one is going to be input and output. Most of these are ranked easy. I sort of thought what I would do, I haven't done these problems before, so it's my first time going through them. And I thought, let me just start by just working essentially from start to finish. I'm working in HackerRank, which is a really great website. If you're not familiar with it, I think it's certainly worth knowing. This one and LeetCode are the two that I use personally. And I have a subscription to LeetCode and a subscription to HackerRank. So let's get into it. So right now we're going to practice reading input from standard input and printing output to standard output. When we say standard output, we generally just mean the console. So in C++, I can read a single white space separated token of input using cin or console in and print output to standard output using console out. So when we say white space separated, that just literally just means like a space. Yeah. Okay. We declare two variables, a string and an integer. We want to read in the integer. We want to read the input. This is going to be our string, high 5 from standard in. So this is console in. This is the insertion operator. And this will take whatever is in console, so this high in, which was inputted from the keyboard, and gets inserted into the S. So that will take the high, and then it uses this space to denote the difference between the string variable and the integer variable, and then it'll read the 5 in here, and that's what it means by white space separated token. So each one of these is a token. The entire thing is a string because when you input from a keyboard, it gets read in as a string. So this is the exact same thing happens when you do parameters inputting into what we call command line arguments. So let's say you have a program and it takes right off the bat. It takes some values to start running, so those command line inputs are sort of input as strings. So that's that. But once they're input as strings, we do something like this to convert them into like an integer if we want, or a string if it happens to be a string. So it starts as a string, and then it becomes, using cin, it becomes input to a string variable and an integer variable. Okay. We covered this. If we want to print these out, so you notice the arrows are going to be backwards here. So when we're inputting from the string, so we're inserting, this is the insertion operator. And then in reverse, if you think about it, it's actually doing kind of the same thing. So what's happening, or you think about it as extraction, so you think about this one as insertion, this one is extracting. We are extracting these values out of the variable and into console output. So again, over here, we're doing like where the actual console is, so this would appear on the screen. 5. Okay, so we're going to read 3 numbers from standard in and print their sum to standard out. We format specifiers, we print f and scanf. If you saw the last video I did, we did something very similar. So let's do it. So with scanf, you're going to end up with, we use these specifiers, and then we use variables. So, and this is going to be variables. So this is the way scanf sort of looks. That's what we're expected to do. But the very first thing we're going to do, and I think I'm going to start adding comments to these as I work. So we're going to declare our variables. Now let's take a quick look at what we're expecting. We're going to read in 3 numbers from standard in and then print them out to standard out. So, and we should also take a look at the constraint. I do have a very bad habit of skipping these, but sometimes this matters. In the case of integers, this won't make a huge difference. But I mean, had this been some absurdly long number, then yes, we would need to keep in mind what the numerical limit for integers happens to be. But for values that are greater than or equal to 1 or less than or equal to 1,000, there's no problem to store them in integers. So let's get into it. 1, 2, F. So D, this is what we use to specify an integer. Okay, so just a little bit to go over what this does. So we declare our integers here. Oh, sorry, this is actually where I'm seeing is lower than what you're seeing. Sorry about that. So where these integers here are, this is where we declare our integers. This scanf says, hey, we're looking for, we're expecting a string. We expect that the first to read in an integer here. We expect a space, another integer, and then a space, and then another integer. So we have D, which stands in for integers. We could also have had Fs. We could have LFs for doubles, LD for longs, C for char values. So that's how that works. But so what we're doing here, we've declared them as integers. We've declared 3 integers. Now we're reading in 3 integers. Now we're saving. Now this symbol here, this is a reference of operator. And so what we're doing is we take a reference to these integers. So we're not just passing in the integers, we want a reference to these integers, because what's going to happen is this is going to get read, and then the memory of num1 is going to get filled with this value. And that's why we take a reference to them. So think about the connection between integers and what we're doing. So once we've done that, the rest of our task is relatively straightforward. We could just do this. I'm going to tell you why I'm not such a big fan of this. Yeah, that's what happens. So what we've done is something silly. So we've returned num1, num2, num3. Great. But we've returned num1 to the main caller. So which means I've taken the sum of these values, but nobody is listening to this. The system expects this. Let's try that again. I have one, two. Ah, shocking. So, what is this? So what have we done here? All fairly simple stuff. We used scanf, and fortunately for us, C++ works the same way. So printf takes a string, so this is going to be a specifier string, and then it's going to have variables that are comma separated. So just clean up here. Great. So first thing we do is we declare our variables. Then we use scanf, and we pass in through reference our 3 integer variables, and we save to receive the value that we're scanning in from the command line or from input. Then we do simple addition, nothing new here, and then we print it out in a very similar way. Again, we only need one of these because we only have one integer, and this goes out. The reason why this was nonsense is because the program is expecting output to console. Just doing this outputs nothing to console. It returns this value to the main caller. But that's not what we're trying to do. We're trying to print this out to standard output. We're trying to print this out to the console. Submit code. Yay, that worked. And we move on. Let's talk about pointers. So, a pointer in C is a way to share memory across different contexts, primarily functions. They're primarily used whenever a function needs to modify the content of a variable of which it doesn't have ownership. So, in order to access the memory address of a variable val, we need to prepend it with the ampersand symbol, which is exactly what we just did, actually. So this here, this is the address of, and that will give us the memory address of a variable. The memory address is assigned to a pointer and can be shared among various functions. When I first started programming, when they talked about pointers, they talked about it like it was, I forget the name of the Lord of the Rings villain, but it's sort of like, oh my god, we're going to do pointers, it's going to be very scary. And I actually kind of wish they hadn't approached pointers that way, and they just said, oh yeah, these are pointers. Pointers, unlike, so when we think about it, a variable holds a value. So if you have a variable x is equal to 5, then the variable x holds the value of 5. What a pointer does is a pointer doesn't hold a value. A pointer holds a memory address. And what the system does is through the pointer, you can dereference it to follow the memory address to wherever that address points to. And that's super useful because then you can, like, from your pointer, you can modify a separate object just because you have a reference to it. So that lets you do stuff like have containers of pointers and do all sorts of fun stuff with it, but there's really nothing to it. Variables hold values, pointers hold addresses to things like variables. Hopefully that's clear. Hopefully this example, which I haven't done yet, will make it pretty clear. So that's all that this is saying. So, and we read this way. So P here, make sure this is visible on your screen. So P is a pointer. P is a pointer to an integer. That's all that means. So you just read it. You read it backwards here. So you go, P is a pointer to an integer, and since it is a pointer to an integer, it doesn't take like 5 or 6. It takes the memory address of a variable. In this case, val I think is an integer. Okay, well, val would have to be an integer. The reason why I know that is because P is a pointer to an integer. So val must be the address. So ampersand val must give me the address of an integer. And that's all that's going on. That's all that pointers are. You can do like a billion really fun things with them, but that's all we're talking about at this point. How am I doing for time? Next time I do this, I will have a stopwatch. Just to make sure. Perfect. Yeah, 15 minutes in. Awesome. Okay. So, in order to access the memory address variable, we use the address of operator. This memory address assigned to a pointer can be shared among various functions. To access the content of the memory, we use dereference of operator. Now you might say, well, isn't that the same thing as how we declared it? It is and it isn't. This will do a dereference. And a dereference, all that means is pointers hold addresses of variables, which means that when you dereference it, all you're saying is, hey, I've got a memory address, but I need the value, dereference. So I've got a reference to a variable somewhere in memory, because I've got the address, and all an address is just a reference to where you live. You live on a street. Your street has you live on a street with a house number or apartment number, and that is a reference to where you live. You don't live at a number. You live at it. That number lets someone find where you live. You actually live in some other structure, but that number lets someone find where you live. And so that's all that's happening. And when you dereference, that's like, oh, I'm actually at the house. So that's really what we're doing, is that like someone gives you an address, that's a reference. When you actually arrive at the front door, you dereference. You sort of dereference that address, because now you're at the actual value, and that's all that's happening here. So this is a function called increment. It takes a pointer to an integer. It dereferences that pointer, and then it adds 1 to itself. And we'll sort of see how that works. So let's go through our function here. We declare a variable. We read in from the console %d, and as we said, %d is just an integer. And then we take that value that we read in from the console and we assign it through the reference of this integer, we assign it to a. That's all that's happening here and here. Then we take a reference, because a pointer needs an address of a variable, so we couldn't just put a here, because a is 5. 5 doesn't mean anything to this pointer. So we need to pass in a reference. Pointers need addresses, so we need to get the address of this variable. We pass it here. We dereference it, so now we get the actual value that's here, and we add 1 to it. And then when we print this out, this should be the a value plus that we started with here plus 1, and then we're done. So let's go for it. So let's look at our input. Our input will contain 2 integers, a and b, separated by a new line. Output, I need to print the updated value of a and b on 2 different lines. Input and output will be automatically handled. So I just need to do the update function. That's convenient, but let's take a look at it anyway. We declare 2 integer variables here, a and b. Oh, sorry, I need to make sure that's always in the high end bar. We declare 2 variables, a and b. We have them here. Now, again, we have PA is a pointer to an integer. So we read it this way. PA is a pointer to an integer. Okay. And we assign that the address of A. So PA holds the address of A. And again, we do the same thing. PB, I'm sure you're starting to get why it's named this way, pointer to B is a pointer to an integer, and it is assigned the address of B. That's all that's happening in the first 2 lines. Then what do we got? We take 2 integers, we read those in from console, and then we assign them to the 2 values. So now A has whatever value we get from console, B has whatever we get from console, and now we do an update and then we print it out. So we expect that update. What is the updated value? Here we go. We want to set A with the sum and B with the absolute difference. So this is what we're doing with each value. So the reason why this is a void function is because we're not actually returning anything to the caller. So so main is the caller. We called update, but we actually don't want a value out of update. That's not what we're doing. What we're doing is we're actually doing 2 different things to these values. And so pointers allow us, so when you have a function, you can only have 1 return value. So let me start typing and do a little bit of talking. So without the use of pointers, you could do something like this. You could say, actually, I'm going to return an integer, and I'm going to have a function. I'm going to call it update A. It's going to take an integer. Notice it's not a pointer, and it's going to do some work. And then it's going to return. It's going to return the A value after I've done some work to it. And then I could do the exact same thing for B. And it's giving me problems because each variable name has to be separate. So in this case, what are we doing with A? A plus B and then A minus. So you can do something like this. You could do int A, int B, int A, int B, declare sorry, I will work on making sure I'm always at the top of the screen here. Okay, and then you could do this. So what you could do is you could actually do this all separate. So if you want to get, and then you would do something like this. So then you, oh, so you wanted to update A. Okay, great. So then you want to say, okay, well, A is equal to update A comma B, and then B is equal to update B, A comma B. And you can do the exact same thing that we're doing. Now, the reason why without references, you have to do it this way. Because when you pass in A and B, when you pass them this way, what we're doing is we say we pass it by copy, or we pass it by value, which means that you're not actually taking this memory address of A. That would be with a pointer. You're just passing the value of A. Which means when you do whatever work you do to A here, you add it, subtract it, it doesn't matter. This A, even though the names are the same, are not related to each other at all. You have copied a new value. This could be X, Y. It would be the exact same thing. It doesn't matter because those two variables are not related to each other at all. So I hope that's clear. So, but because you can only return one value at a time, so you can only return one value from a function, you would have to have two separate functions if you wanted to do it, because you need to update each of these values individually. A has its own separate value and B has its own separate value, and you can't return two things at once. However, if you get rid of this and you pass in a reference, now you can do anything you like, because all you have to do is say, well, wait a minute, I've got a reference to A and B. That means if I change A, I change this A. If I change B, I change this B. And again, just so we're clear, the names don't matter. It really doesn't, and we'll do it with X and Y just to make sure that's perfectly clear. Because what we're doing is we're saying, hey, A doesn't matter either. A is a memory address that holds an integer. A is just a user convenience. The computer doesn't necessarily care. The computer's got a memory address and it's got a value. That's all it needs to do its business. For us, we use this because obviously that abstraction makes a lot of sense for us. So we'll do it like this and we'll say, okay, great. So now we have to do a bit of work. So the first thing we're going to do is we're going to add A and B together. So I'm going to say X plus equals Y. Oh. In case you're curious, which you should be, why doesn't that work? X plus equals Y. We've got an integer, right? We've got one integer here, and we've got another integer here. We're just going to add Y to X and save the value as X. Why doesn't this work? Like, why can't, like, X? Fine. Okay, let's do it a different way. X plus Y. Let's just be explicit about it. It doesn't work either. What am I doing wrong? You probably guessed, so I'm not going to belabor the point. X is not an integer. This is a memory address. So what I'm doing doesn't make sense. I'm trying to add two memory addresses together, and that doesn't work. Like this fails. What I need to do is I need to say, well, wait a minute. What exactly is X? X is a memory address. So if I need the value that's in X, which is what I'm trying to do, then I actually need to dereference X. So you can do this, because you can't do this. But if you dereference x, so now the value held by this memory address is now 5. So we want to say, actually, it's now equal to y. That's actually not what I want either. This is what I want. So this is equivalent to the value of x is equal to the value of x plus the value of y. That's that. Great, so we've done the first one. Now, let's deal with this absolute value. And let's see, how will we do that? There is a math function in C++ that will do this, which will give us the absolute value. Excuse me. So, is there a way to do this without the function? So, what if I do this? And then I want to say that the value of y is equal to x minus the value of y. This will work. This will work for all values where x is greater than y. But if I get a negative value, I do want to make sure. We'll do it the long way, then we'll see whether or not we can find sure. If address of y is less than 0, semicolon. Okay, and again, there's no return, so let's run the code and see what happens. Okay. Sorry, I need to move this up so you can see this size. Okay. So what didn't it like? Well, first of all, my input is backwards. So in 4 and 5, so of course the first part is correct. Second part is not correct. My output is 4. And output is 1, 5. So okay, that's right. So 1 minus 5, 1. 4 minus 5 is -1. If -1 is less than 0, y multiplied by -1. 1. Why is my output 4? Why is my output 4? Well, sometimes things like this happen. So we figure it out. It would be really great to say that, like, oh, you always know what the answers are, and it's always very clear. Sometimes it's just not. And you're like, I don't know why. Something is happening. So we figure it out. Like I said, I don't do any of these ahead of time. I always do them live, kind of for this reason. I think it's important to see that, like, sometimes things just go totally south on you. So I want to see what's happening. And so you debug code. That's just how it is. So the value is 5. So this is our y value. So this is our y value. And this is our so this is our y value. So this should give us 1 for y. Instead, it gives me -4 y. What is the value of course. That's really funny. That's really funny. What is the value of x here? Okay, so in case anyone is curious, what the heck is going on? As I was really confused, I'm like, what the heck is happening? Remember what I said about passing references to values? So the reason why that's important is because the inputs here and here are 4 and 5, right? So that means when we start, actually I will type this out as I go. So I will show you why that didn't. Y equals 5. All right, that's our starting. That's our starting. Great. So then, this is the first thing that we do. We say x plus equals, the dereference value of x is equal to itself plus the dereference value of y. So, y is equal to 5. But what is the value of x? Well, it's not 4. It's 9. Which means when I come here and I expect that this will give me in this case 1, it doesn't. It gives me 4, well in this case negative 4. So that's the difference. So how do we deal with this? Well, what you can do is get a value for y. Sorry, say that again. So what this will do is int is just a copy. It just copies this value. It doesn't have any relationship to y at all. So when y changes, which it will, folder will be absolutely the same. So let's try this again. -4. And of course, if I grab the that. Give me 5. This is correct. X. X 9, fine. Four, fine. X minus y, 5. Perfect. So you see here, sorry, it does get cut off on the screen. But what we're seeing is that the values are now correct. So meaning that like what I need to do now is say if y is less string 0. There is a math.abs function which will do this for you. And when you're doing a live stream, try not to be really hasty and forget to do super important things like dereference points. Great. Whew. That was fun. So yeah, again, this is the reason why we do these things live, because it makes sense that people can actually see that, like, this is sometimes what it looks like. It's not usually on a problem that's trivial, but you'll be surprised at how often you may find yourself coding and getting stuck working on a problem or trying to fix something and sort of seeing, well, wait, how come it's not doing what I expect? And so missing something fairly obvious like this is that, like, we are in fact changing the x value is super important. So you can get rid of some of this stuff. Oh, let's leave this. This is that. Explains this. This explains this. If this were real code, I would not leave those there because obviously these values are completely different. And then if we probably use, I don't know if it's in this tier, which let's try it. Nope, it's not in the standard library. It really doesn't matter, but there is a math.abs function there. So I can't remember. There's an absolute value function which would do essentially this bit of code for you. But since we're just doing it live, I think it makes sense just to keep going. On to the next one. All right, let's talk about arrays. An arrays are a series of elements of the exact same type placed in contiguous memory. Contiguous just means like an unbroken block. So if you think about it like a chocolate bar is a contiguous block of memory, or a contiguous block of chocolate. But they can all be individually referenced, and that becomes super useful. We do simple declarations, very similar to how this is declared in Java. And again, you say this is the name of the array, this is the number of elements in the array, and this is the type that can be held in the array. Indexing of arrays start at 0. That's sometimes tricky for people at first, but once you get into it, it's no problem at all. So if there are 10 elements in an array, it'll go from 0 to 9, not 0 to 10, which would be 11 elements in the array, and not 1 to 10, because it is 0 index, so 0 to 9. So we've got an array of some number of integers, and I have to print the number of integers in reverse order, okay? So the first line of input gives me the number of integers. Now this is super important because arrays, raw arrays in C++ do not tell you how many elements are in them. It's a very simple container, which means if you need to know how many elements to go across, you have to know how long the array is. Now, when we do things like strings, which hold like an array of chars or an array of characters, what we'll do in C is they'll do a null character at the end, which gives functions like string length the ability to sort of say, okay, read until you get to the null character, and that's when you know that you're at the end. And so those are sort of some of the tricks that have been set up to deal with the fact that you don't know how many elements are going to be in an array. But if you don't have anything like that, then you do have to do it like this, where you're like, look, you got to tell me how many elements are in the array. And in this case, we know that there'll be less than 1,000 elements in the array, and we know that each each integer in the array will not be greater than 10,000, and it will all be positive values. So, if this is 4, telling us the number of elements in the array, this is the array itself. We're going to print 2, 3, 4, 1. We're going to do it that way. Great. And unlike the last one, it's going to make us, oh, it was C math. Yeah, that would, sorry, I believe that's what I was looking for in the last, for the last problem. That was very close. Anyways, so let's do this. So first thing, let's get rid of this, and let's break this down into what we need to do. We need to declare a variable. This is my. We need to declare variables. We need to read input. We need to read output. Reverse. Yeah, that's it. So let's do it. So we don't know. We need to get, so sorry, first things first, we need to do three things. We need to get the length. So that will tell us how many elements. The second thing we need to do is we need to read in all of these values into, I'm going to read in a string. Space. That's fine. So first A is fine. So if we were to do scanf, GD, we take memory address of length. We're good. So now we've done the first value. But now we have an unknown number of integers, and we need to get them all into an array of some kind. Well, an array. So, how do we do it? Good question. I don't know off the top of my head. I'm not exactly sure what way makes the most sense. We have a string. But you can't pass a variable format. Yeah, let's do it. So when in doubt, look up C++, read string. I do without doing string. Feels like not what they're asking for here. String's going to do what I want. That's great. Just wonder if there's yeah, these are all things that you might find yourself doing and probably will. We're just trying to figure out, okay, what is the best way to do this? to do it in a string string. It just seems like overkill for where we are in the process. Well, let's try some things. This is what I want to do. This is a very strange problem because I can't do what I wanted. What I want to do is this, but you absolutely will not let me do this. So I can't do this. And then will it let me print? Let's just see if I can get. Zero, first element. Huh. Nice. Well, that is convenient. Perfect. Okay, I actually was not sure whether or not this would work. So basically what I want to do is this. I want to declare the variables that I have. So this is the length, which I don't know. And then I wasn't sure whether or not it would let me do an integer, a non-defined, like a non-constant integer for the length of an array, but it will, which is great. So the first thing I do is I scan in the length, and then I use, if you remember what I said in the last talk, if you know the number of times you need to iterate through a loop, then go ahead and use a for loop, because that's really what it's for. And so what I'm doing is I'm just scanning in each integer. And here, the other way to do this would have been with a string stream, which basically takes the entire thing that you have, takes the entire string and puts it into a process by which you can go in and then parse through all of your individual elements, which for where we are in the process is a bit overkill, but this will work, and that's good. So, the variables, let's move this up, the length, about 10 minutes. We'll probably finish here. So the length. Array. That's all we're doing here. So a couple things. So R at I is actually the index. So every time this loop runs, this I will be incremented by 1. And that's how we move down the chain of the array. And we can't just say, hey, give me the value of this space in the container. We want the memory address of the space in the container because we're actually going to fill it with the integer that we're reading in from the console. And now, when we print it out, we say, okay, we're just going to print it out in exactly the same way, except we need to reverse it. So we're going to do this. So I'm going to write this. You're going to tell me why it's wrong. Zero, you're going to tell me that this is wrong. This has to be changed. this to the semicolon. Great. So, what have we said here? We're going to go for integer I is equal to the length of the array. As long as I is greater than 0, we're going to decrease. This will not work. And let's run it. Let's see why. It only gives me these two values, which means it didn't get the last one on either end. Now the question is why? Well, first of all, I is equal to length. But we know that an array is actually, so again, if length is equal to 5, then what does that mean? That means if that's what we're using to size our integer, that means we're going to end up with something like this. Right? So there's a 0 position, there's a 1, there's 2, there's 3, and there's a 4. So this isn't really quite what we want. So it starts off where I is equal to length. But that's not quite right. So what we want to do is we want to do length minus 1. And then it goes so long as I is greater than 0. But we also need 0. We also need this first value. So then we want I to be greater than or equal to 0. So let's run that and then see how close that gets us. Oh, you got to delete. If you're going to do scratch notes, you got to delete them before you run the code. Okay, and we sort of end up with these two, but not the rest. Why is that? Printing. Length is 5. So, length plus 1. Length is 4. Sorry, I'm just for like 0, 1, 2, and 3. I would expect this to be length minus 1, where I is greater than or equal to 0. And then I'm decreasing I. Yeah, that's fine. This passes. Submit it. But it should start failing because do test case. Yeah, it's fine. All right, let's figure out why it's not. Working correctly. What is the difference? Sometimes this does happen to you, where you're like, you have an idea of what should happen, and then it doesn't, and you go, oh, that's very strange. I is equal to length minus 1. I is greater than or equal to 0. I should decrease down to 0. Let's submit the code. let's do this. Let's not try to access the array. Okay, so what was blowing up was it doesn't like this indexing. So let's figure out why. Like, one thing you shouldn't do is like, don't panic when things go south. That is inevitably bound to happen. Just work it out. -1, I is greater than or equal to 0. So let's say I is equal to 1. Yeah, no, it really builds up. Why? Let's just do this. When in doubt, start with what you know. Check that the index is correct. So what is it doing? Uh, 8373. 8373 is not the length of this variable. So what is it doing? Why is length? So let me print out one value. So let's go to that. So it's 0 to start with. After we read in the value, the output is 8. After we read in all of the array values, the output is 8373. Something very bizarre is happening. I never change the value of length. Length is a straight integer. I is less than the value of length. Length does not change. Value iterated. In case you're curious, this is my personal nightmare. Yeah, so these are just glorified print statements. So as you can see, this value here, when I read in length here, it's 8. When I read in length here, it's 8373. This is the reason why it's blowing up down here, because length is wrong. Okay, so let's do something a little crazy. So let's say we have length, copy. well, something unusual is happening there. Let's copy. This is 66726, 321, fine. Let's put a space. And it doesn't like this because length copy, as we said, is one too big. This is what I was expecting. Instead of printing out. Yeah, so this is what I'm expecting. Okay, so let's run the code. So let's see the code. I think I'm out of time. I am, it's 1 or 2. Okay, I will finish this one and I will upload the solution. Thanks for watching. This is not exactly the stream I planned to do today. But to be honest with you, these sorts of things happen. You find yourself in weird situations and you've got to debug code. A lot of programming is problem solving, and it's just stuff that happens. All right, have a good one. A lot of programming is problem. I don't know. It's my fault, people, to be honest with you. shocked at how poorly that went.